Dear students, good morning everyone. Today we're going to learn about data communication in computer networks. These are the topics we're going to cover today. So first topic is introduction to data communication. Second, basic components and characteristics of data communication. Third, types of transmission modes. Fourth, line configuration or physical structure. So first we move on to the data communication. So data communication is nothing but the process of transferring data from one device to another device between two devices. So it allows electronic and digital data to move between two networks. So we need a transmission medium to transfer the data or exchange the data. What is the transmission medium? We use cables, wireless signals, etc. So it enables the communication between the computer, servers, and other network devices. Let me say the example of data communication. If you're connecting your laptop to a Wi-Fi network, this action requires a wireless medium to send and receive data from remote servers. So data communication refers the process of transmitting data between two or more devices using some form of transmission medium. So to better understand, let me explain the key characteristics of data communications. This is the key characteristics or fundamental characteristics of data communication. So first one is delivery, second accuracy, third timeliness, and fourth one is jitter. So delivery. So data must reach the correct destination accurately. The sender sends the data to the destination. So the sender wants to know the correct destination address so that the receiver can receive the data on time. Accuracy. So the transmitted data should remain intact and unchanged during transmission. So accuracy is the data must be delivered as it is, and it should be received the data without any errors. The system must deliver data accurately. Next, timeliness. Timeliness, the system must deliver data in a timely manner. That is, data should be delivered with an appropriate time frame. And next one is jitter. So it refers to the variation of arrival time of data packets which can affect audio or voice communications. So these characteristics ensure that communication is smooth, reliable, and efficient. So these are the characteristics of data communication. Now let's look at the key components of data communications. So these are the data communications components. First one is sender, second one receiver, third message, fourth transmission medium, and fifth one is protocols. So first sender, those who are sending a data, that people are sender, the device that sends the data, the device that sends the data to the receiver, that is a sender, and those who are receiving a data, that people are a receiver, so that is a receiver device. Message, the actual data being transmitted, the message or information or data being transmitted from sender to the receiver. And transmission medium, the path are connecting between two devices, so the path through which data travels, for example wireless, etc. So next is protocols. Protocols. So set of rules that govern data. Set of rules that govern data. Examples, some protocols is TCP/IP, HTTP, FTP. So TCP/IP is Transmission Control Protocol, Internet Protocol. HTTP, Hypertext Transfer Protocol, and FTP is File Transfer Protocol. So these are the components of data communication. And next we move on to the transmission modes. Transmission modes. So in computer networks, transmission modes defines the direction of data flow. Direction of data flow, and they are categorized in three. One is simplex mode, half duplex mode, and full duplex mode. So transmission mode is sometimes referred to as communication mode. So there is three categorization. One is simplex mode, half duplex mode, and full duplex mode. So first we learn about simplex mode. So simplex mode, data flows in only one direction, that is unidirectional. That is unidirectional from sender to the receiver, not from receiver to the sender. Only one direction, that is unidirectional. The data flow in one direction. So for example, think of a radio broadcast. Think of a radio broadcast. So but the station sends information, but the listener cannot reply. But the listener cannot reply. This is a simplex mode. So simplex mode, the communication between two devices is only one direction. The sender sends the data and the receiver receives the data. There is no data sent by the receiver. Next, off duplex. Off duplex mode is data can flow in both the directions, but only one direction at a time. But only one direction at a time. For example, if the sender sends the data, the receiver receives the data, and after receiving the data, the receiver sends the acknowledgement to the sender. So once data is received, the receiver after receiving the data, the receiver sends the acknowledgement to the sender. So another example is imagine two people talking in a walkie-talkie. So where one people can speak at a time. One people speak at a time. So off duplex is a bidirectional but not at the same time. So this is an off duplex mode. Next is a full duplex mode, transmission mode. Third one is full duplex mode. In full duplex mode, both the station can broadcast and receive the data at the same time. So transmission in both the directions simultaneously. The data will sense it between two devices at the same time. So for example, imagine so people is talking in a phone call where both the parties can speak and hear each other at the same time. Each other same time. So this is an example for full duplex mode. So first one I want to recall it. So transmission mode, there is a three categorization of transmission mode. One is simplex mode, full duplex mode, and off duplex mode. So full duplex mode is the transaction, that is data transfer between two devices, is bidirectional at the same time. Simplex mode is a unidirectional. Only sender can send the data. The receiver cannot send the data. It is unidirectional. And off duplex mode is a bidirectional but not at the same time. A best example is walkie-talkie. So let's move on to the next topic, line configuration. So line configuration. So a network is nothing but connection. A network is nothing but a connection made through a connection links. Made through a connection links. We have to connect the device. We need a link. We need a cable or we need a signal. So we need a connection between the two devices to transfer the data. So devices can be a computer or printer or may any other device that is capable of send and receive the data. So a network consists of two or more devices connected through a link. A link is a communication path that transfers the data. That transfers the data from one device to another device. So these are the possibles. These are the two possible types of connections. These are the possible two types of connection. One is point to point, another one is multi-point. So let we see about the point to point. So point to point, this is a point to point connection. Point to point line configuration provides a dedicated link between two devices. So point to point is dedicated link between the two devices. It is a multi-point. If we move on to the multi-point, a multi-point is the line configuration is one which more than two specific devices share a single link. Share a single link. So if it is a multi-point connection, there is a multiple devices will be connected in a single link. Multiple devices will be connected in a single link. So this is the types of line configuration. The first one is point to point and second one is multi-point. So point to point is connection between two devices and multi-point is connection between more devices with a single link. A single link. So I'll stop here. Thank you, students. We'll see you in the next session in an interesting topic. Thank you.